Okay, so I just want to document my latest SJR V4 build. I'm going to send this build off to a friend for some testing. He may video that and update that on video or just share with me, I'm not sure, but I just want to document the component values. You can see there I have two little tiny 200 volt capacitors. And let me just put this image here. I'm sorry, I'm not sure what sort of capacitors these are, but they're rated 200 volt. And maybe they're mica or something. Maybe you can tell me in the comments if you happen to know what sort of capacitor that is. But I got two of those on the circuit, and I just want to point that out so that if you see this running with the electrolytic disconnected, it's running on the energy reserve that's in those two little 200 volt capacitors. Now over here on the electrolytic side, I have the same value as I had in the previous videos, a 470 microfarad electrolytic. Now this circuit has a few switches that I can switch to try different settings, and I'll go over that as well here in a second. Let me go ahead and start up the circuit. Now this is a low energy use blink mode. The frequency is a little higher than my camera can pick up here, a little more steady, but not a lot. And that's the most, if you just want to run this circuit for a long duration to do some testing, that is really the mode to test it in. And on that mode, I can disconnect from the electrolytic, and it's running those little 200 volt tiny caps now. And I'll reconnect it here, and I'll go to the next mode. The next mode here is a steady light mode. Now this is very similar to the performance I was having with the variable air capacitor. I've not actually done a timed run on this 470 microfarad. I'll probably do that on this video, later in the video, just to document it for my own reference in the future. But that is the mode that this is really tuned for running at. Now I have one other mode that I can flip it into here, and this is an ultra bright mode. And you can see that is really bright. Now if I run it too long in that mode, it will drain this little electrolytic pretty quickly. This is really tuned up to be run in this mode. And we'll go ahead and do a long run test on that mode here later, like I said. What I want to show right now is the way this circuit performs in this mode, even with the electrolytic out of the way. So just touching it to the 9 volt, that's it running on those little 200 volt little capacitors there. So that's really interesting. And I'll put it back on low mode. Now unfortunately, the camera doesn't really pick up because of a frequency issue, but this runs on quite a while on just those little 200 volt capacitors. So that of course is very interesting to me. And so that's one of the modes there. Now I'm going to go ahead and just connect this up to this capacitor. This is a 10,000 microfarad 10 volt capacitor, and this is just so that I can document the performance I'm shooting for the flashlight type devices. So we'll go ahead and connect this into here. And a 10 volt electrolytic capacitor like this is pretty much an instant charge type device in a circuit. If you have a flashlight or something of that nature, you can charge this instantly. So I'm going to go ahead and discharge that, and we'll run the energy out of the little 200 volt caps here, so the whole thing is completely discharged. And we will do a instant charge here. So let me go ahead and put this in the medium mode to start with. So the circuit is charged and off and running. And what I want to do now is show you the light output. It's kind of hard to see. I'm here, it's daylight. You can see some light coming off there. It's definitely producing some visible light. But let's go ahead and go here to the high power mode and show you what we're looking at. So on the high power mode, this is some pretty serious light. It's not dark in this room. Maybe I can bring this into a place that's a little darker here. I'll begin to show you, unfortunately, I'm not going to really have anywhere all that dark, but you can see there's some serious light being thrown off this circuit running it in this mode. So, this is really where I'm going with the circuit, because I can do an instant charge type effect on this mode with just a little shake with a shaker light and get this kind of effect, and that will just be super awesome. So stay tuned for that upcoming. Again, this is the low mode that I'm going to go ahead now and switch over for the remainder of this video and do a duration run test on this lower mode. So tell you what, I'll set it up, be right back. Okay, so we're back on the little tiny guy, the little 470 microfarad, It is running in the medium mode at this point, and we're going to do a duration run test. Now, in order to do that, I need to discharge. This has been running here for a while, so let's go ahead and discharge this with the ultra bright mode. This will just run the energy out of the electrolytic. And it's running down there. And I guess while that's happening, I can go ahead and just flip this over and show you. It really is kind of a crude build here. But anyway, you know what? I need to discharge this quicker because that's going to take too long. So let me go ahead and put this back. Now it's going to be running in the medium mode. This should be discharged. We'll go ahead and connect up here. Yes, we are discharged. All right, so here we go for the long duration run test. 3, 2, 1, energize. And it is off and running. Now, I'm not doing the microwave test or anything in this video. Many people have done that. This circuit's being replicated all over the place at this point, so you can feel free to do your own tests with that. The schematic's up at laserhacker.com. You know, there's no need to worry about those kind of tests at this point. Again, even though in this medium mode it is throwing some light around, so anyway, just trying to do something interesting with it while this video is going. Here's some darker area that you can actually see that even on this low mode, it's actually throwing some light around. I don't really have anything in here to read, but you know, if I did, actually we might have something up here. There we go. And these are blue LEDs. I tried that because on the coolest circuit, you know, he was doing some blue LED stuff, and I had some around, so I thought, hey, I'll just try that. Anyway, it's a low light output mode, but it's certainly outputting some light. And, you know, for this test, that's interesting. I mean, you saw this on the higher output load, and you can see that we can produce some very practical light with a little larger electrolytic capacitor, but I think a lot of us have been doing run testing on a 470 microfarad like this one, so that's kind of establishing a baseline for runtime. And I know in one of the Akula circuits, you know, early on when I was trying to replicate, you know, what Akula was up to, I noticed that he had a 330 microfarad capacitor, and I was looking at his LEDs and they looked to me to be lit, you know, about this bright, and I was looking at his runtime and just, you know, kind of thinking that didn't really seem achievable to get that kind of brightness and runtime on electrolytic of that size and value. And now I seem to have arrived at a solution to achieve a very similar effect. So we're in here, you know, a couple minutes. This is kind of interesting because this long duration run that you're seeing here is really the first time I have tested this particular build at this particular light level. So I really don't know how long this is going to go on for. But we'll let it run down, you know. The blink mode, you know, these things will run a really, really long time. So that is a mode to definitely test. I guess I can talk some about these circuits, some of the experimentation I've been doing. I have noticed that when I get my multimeter in play here, and let me just bring one over. You know, this one is a 0 to 50 microamp multimeter. I really need one that's 0 to 5 microamps for better resolution. Actually, this circuit in a certain configuration is pulling 0.1 microamp, you know, with visibly lit LEDs. So I really do need a better meter, but let me just tell you what I noticed. I've noticed, and this is contrary to what I used to think, but I noticed that the current draw does not necessarily reflect the runtime that you'll achieve. For the longest time, I would design a circuit like this, and essentially what I would do is I would adjust the current draw for the lowest possible current draw, maximum brightness, and then I would assume that the circuit, you know, if it's pulling 1 microamp, it would seem to me that it would run a lot longer on the capacitor than if it was pulling 10 or 20 microamps. That has come out to not be the case with this circuit in my experimentation. Now, to really test and verify that, I've done a lot of testing with just these little 200 volt, little itsy bitsy capacitors there, and doing run testing. And for instance, I've noticed a lot of times that the runtime would be longer pulling 20 microamps than it would be, say, pulling 10, just depending on the coil configuration. You know, how many winds? It's usually mostly the winding ratio. Now this is a very interesting coil. It's the first I've tested like this. And I guess since this is running on and on, I'll go over that as now. You know, let's just go over that now. This has a 4 wires wound together, so kind of like a bifilar winding. I've got 4 wires. They're all Litz wire and they're wound together. And basically with this coil, I started with the first layer. And you can see I touched one of those and it kind of threw the circuit off a little bit. But I took 4 of those wires and I started on the primary winding. And if you have a bobbin, and this one already has some stuff on it, but we can talk about it, you'll still get the idea. I took those 4 wires and wound them together and I came down 1 layer all the way down, 1 layer all the way back up. That's my general rule. As I remember, that's what I did in this one. Maybe I did it, you know, 3 times, but I'm pretty sure I came all the way down and all the way back up. And that gave me 4 wires here on the initial windings, and you can see they're all marked white here. And then I came on with, you know, 4 sets of those wires again. This is Litz wires, so you know there's a lot of wires in there. I came on with another 4, and I just completely filled the coil out. And you know what, thinking about it, looking back at how I did this, I think it was more than 2 layers in this particular one. I think I came out here about 1/3, a quarter to 1/3, and filled it with the initial primary and then wound on the secondary. So anyway, that's the basic idea there. Now when that was done, I basically connected these ends up in a fairly interesting way. It's a way that I've experimented with on these kind of devices in the past, and this will give a good example. You know, in this case, this primary winding has this yellow wire and this purple wire, and they're wound together, the same as what I'm explaining I did inside here. You can see this is starting to blink a little bit. That's not visible to my eye. To my eye, these are still solidly lit. But you know, the camera, it's frequency stuff. So anyway. So what I was saying is that these wires, basically what you do is, so in the primary, what I did over here, the way these are connected, is I essentially take the, like in this case, the purple wire, and I come down here and I connect it to the yellow wire like that. And that just connects those and makes that kind of like one longer wire. But it's kind of it has some interesting properties and effects. So I essentially did that, you know, with all 4 wires here in the primary. Now up here in the secondary, I did that with 2 sets of the wires and I left 2 free, and that was to experiment with some, you know, feedback loop stuff that I wanted to experiment with. I don't have time to do that, so you know, maybe that can be focused on in the future. You know, I'm going to build up more of these and then keep improving on this. You know, at this point, I think there's still room for improvement. So anyway, that's kind of what's going on inside that core. Other cores perform, you know, they all perform at differing levels, but this one does a good job for runtime as well as brightness. And that's some of the things I'm looking at on this particular circuit. So again, to my eye, these are just pulsing along. They're definitely, to my eye, getting dimmer at this point. I don't think they're throwing nearly as much light as they were earlier. But the circuit is still very, very lit and running along. So I don't know how long that was, guys. You can, you know, take a timer and look in the video and see when I start this runtime test, you know, how long it goes. But we're probably in, you know, 5 minutes or so if I had to guess. So it's actually run on longer than I kind of anticipated it would. So anyway, it's probably a pretty good record for 470 microfarad. Now there's one guy out there who's done some replication, and he's getting a lot longer runtimes on the same value capacitor. But what I noticed is his capacitor is a larger size. So even though the microfarad rating is the same, it's a larger capacitor. I can tell you right now, this circuit is so finicky, and it's such a balance between the components and the amount of mass, and you know, all of these things have to be in balance, that it wouldn't surprise me if you took one capacitor that was a larger volume, that was a 470 microfarad, and then a smaller one, and actually measured very different runtimes, just because of the mass of the material inside the capacitor. So there are just a ton of variables to play with in this circuit, and it can either drive you crazy, or if you have a personality like myself, you'll probably just have a good time exploring it and learning more. So I don't know, guys, I'm running out of stuff to say. I really didn't anticipate it to run on and on and on and on like this. The frequency has changed. You can definitely tell that on the camera, in that the stability of the blinking has changed quite a bit. But you know, there's still, intensity-wise, they're still lit, you know, very visibly. So you know what, this sort of, we may, as we perfect this circuit, you know, instead of running time tests, and I would encourage people who do the replication to go ahead and show your circuit, you know, show its light intensity, maybe shine at some paper or whatever, like I did in this one. I didn't do that great a job on this. I should have put a paper up in the wall in that dark room rather than shine the light bulb. But, you know, it gives a general idea. Those of us who are trying to build circuits like this, we can look at that and we get an idea, you know, what's going on. But it's probably a good idea for all of us to move, at least any of us that are achieving, you know, performance levels like this or greater, to go ahead and move down to maybe a 100 microfarad capacitor. And I may go to a ceramic 100 microfarad capacitor, but we should probably talk about establishing a baseline. And then if we really want to get into it, we could get a lux meter and basically establish a baseline of runtime as well as light output. In the past, I would have said all you have to do is take the lux meter, measure the light output, and then measure your current draw. And that would be a good way to judge the performance of the circuit. I no longer think that way. After seeing, you know, these things run longer, you know, with a greater current draw, or, you know, running a much shorter length of time with a much lower current draw, it's far more subtle. You know, there's a lot of nuances that go into this thing and what makes it perform as it does. So to really do runtime tests, we really do need to establish, you know, a baseline, run with that, see how long the circuit runs, and go from there. So, yeah, this thing, I said that I would document, you know, a time duration test on this thing, and I'm doing that, but I'm just running out of stuff to say. I feel like setting this camera on a tripod, and I've got some other stuff I need to do, but it runs on and on, so. Anyway, that's pretty much it. I'm looking forward to, you know, as I find time in the future, to really bringing this into a serious Tesla torch flashlight. You know, I love the previous Tesla torch flashlights, but I want to come back to that and do something that just blows that previous one away. The previous one, I was still using supercapacitors, and man, you put a supercapacitor in a circuit like this, and it would just run on and on and on, even in the super bright mode. But you know what? I don't want to have to use these supercapacitors. These got incredibly hard to find. And you know, it was very hard to source the parts for the previous Tesla torch, as these got more difficult to find. And I really want to go to the electrolytic. Let me just show you. This is running on. We'll come right back to that. But let me just show you over here what I've got. I've got some of these. You know, these fit inside a flashlight. And these are 10 volts, 82,000 microfarad. So that's a nice size for a flashlight. You know, I've got some ideas to utilize these. These are cheaper, they're easier to come by. And with a circuit like this, even on high mode, you're gonna get a really long runtime. Even using a large, you know, electrolytic. I don't think we have to use these really expensive supercapacitors. So I'm looking forward to going back to this. You know, this gives you the ability to do a single shake and bazam, you're off and running. Now, I also want to experiment with a desktop lamp, like a reading lamp. And that's where I found this big guy. So this is basically a 250,000 microfarad, 10 volt. And I've got some plans for this, to create a lamp that you do a single action of one, you know, you'll just have to follow my videos to see what's going to come along with this lamp. But this will be, again, an instant charge, and then you'll have this reading lamp, and you'll be able to read and stuff, and have just a light source that you never really have to worry about going out. Because these can be charged and discharged, you know, almost an infinite or unlimited number of times. So I've got a progression, I've got a plan. I don't have a lot of time, but in the time that I do have, I'll continue to carry on with this. And all the replication that goes on out there is just excellent, because that helps me. You know, I share all this stuff freely, and I really appreciate it when people share freely back, and we can kind of get a snowball effect going, you know, like an avalanche of experimentation behind this. And if we keep sharing freely, this thing will get better for everybody. And that's really my goal, you know? So let's go ahead and keep sharing, and I will document this stuff as I build the reading lamp. But before I go to the reading lamp, I really also want to work quite a bit on the flashlight using electrolytic about this size. So that's my plan. I have no idea how long this thing's run on for at this point. It's still fairly bright. You know, I'd have to go back and compare it to the Akula video where he shows some blue LEDs, you know, lit. I remember noticing in his video that I could see down into the LED and see the inside of the LED. I think his were brighter than this at that point, but you know, it's possible. A lot of those videos only show the circuit running for a minute or two. It's totally doable, guys. You do not need to hide a battery or a supercapacitor to create a circuit that you can run, you know, for a minute or two showing somebody something on a video. Now, the claims of over unity and the device running on and on for days or hours, you know, that's a whole nother, you know, that's just a whole nother level. And personally, I don't believe in an over unity system in which the energy be coming out of, you know, thin air or just coming from nowhere. The only thing I can imagine is a system in which we get maybe a tank circuit or some system in which the energy is circulating through the LEDs, you know, and back, and doing that continuously, and then trying to get as much LED, you know, intensity out of that as we can. And that's what I keep pushing for. And I don't really worry about the power in versus power out measurements and all of that. That can become a time trap and just a huge, you know, looking for the pot of gold at the end of a rainbow that you can basically, you know, spend your life trying to find and maybe never get anywhere. So I'm trying to make this circuit practical. You know, this is really a test bed for the flashlights. And it is interesting, though, because I saw everybody, you know, a lot of folks are saying, you know, Kula faked the little LED drivers. And, you know, I don't know if he faked them or not, but I will say his videos inspired me to try to replicate that, and I came up with this, and this has great practical value. And it's now possible to create a video where you know, instant charge something, and you know, if your video is a couple minutes long, it's going to look just like a lot of those other devices. And, you know, I'm not using the same driver system. Theirs are much more complicated, and it may be that if you had two transistors and we're pounding this with two different frequencies, that we might reach a whole nother level of performance. You know, this is the ultra simplistic. I love simplicity, but I'm telling you, this is an ultra simplistic circuit. Check out laserhacker.com. I'll put a link to that in this video, just if you want to go see that circuit. I don't know. I must be coming up on 20 minutes here or something, folks. I'm getting really tired of this. I will tell you at this point, it may very well run for an hour plus in the lower blink mode, which again looks much more steady to the human eye than the way this camera looks. So these things are getting dim at this point. They're still plainly visibly lit, but you know, to the human eye they look a little more dim than they do to my camera at this point. But you know what, I don't know if the battery in this camera is going to work, but I'm just going to see if I can't set my camera. Okay, it's I missed a couple seconds there because I had an incoming phone call on my cell phone, and I just declined that because I'm in the middle of this time run test. So we can, you know, add a couple, you know, 10 seconds or so to whatever this turns out to be. And this is just a rough approximate, you know, time test. So anyway, my thought was that I could set this camera here. Yeah, it's not going to work. It's going to fall off. I don't know, guys. This is probably, like I said, it's probably coming up on 20 minutes. I can tell you that it's going to hit 20 plus minutes because these things are going to get dim and they're just going to run on and on and on and on. So at this point, you know, I'm going to basically just say 20 minutes in that medium intensity mode. And who knows how long in the low intensity mode. I'll probably ship this connected to a electrolytic capacitor in the low intensity mode and see if, you know, if it arrives at its destination still running. I did that once before with one of these, and it did arrive still running after all that time. So, but at this point, you know, I just don't have the time to burn today to spend, you know, 20 minutes or more pointing this camera at this little circuit. So anyway, guys, that's really it. Let's all keep experimenting. I'm going to go ahead and play with the switches here a little bit. And maybe I'll even do some finger touching at this point just to see if I can bring some intensity up into this. You know, there's not a lot of points that I can touch on this circuit because of the way it's, let me see if I touch between here and the positive rail. Get a little bit of something. Anyway, I also tried disconnecting and seeing, yeah, look at that. It even wants to run on in the 200 volt guys. So anyway, as you can see, this thing is a bottom feeder, man. It's probably down on, you know, lower voltage now in this capacitor, and who knows how long this thing would run on like this. So I'm stopping the video here, guys. Let's all keep experimenting. This documents the SJR V4 I hope to see some more videos. You know, I'd like to see this on the scope and get people with far more experience than I have on this type of stuff looking at this. So anyway, let's all keep experimenting. I will catch up with you all later. Leave any questions in the comments below. All right, talk later.